Welcome to another exciting episode of A.B. Computer Science. Make sure to have your writing utensils handy to take notes. It was recognized long ago that programming is best accomplished by working in smaller sections of code that are connected in very specific and formal ways. Programs of any significant size should be broken down into smaller pieces. Classes can be used to create objects that will solve those smaller pieces. We determine what behaviors these objects will perform. These behaviors of the objects are called methods. Methods are what an object can actually do, like in our drawing tool example. You've been using methods since lesson 2. Remember that the general syntax is as follows. Parameters and arguments are used to pass information to a method. Parameters are used when defining a method, and arguments are used when calling the method. We use the drawing tool's forward method to move myPencil object. However, we must tell the forward method how far to move, or it would not be a very useful method. We do this by passing an argument to it. In our example, we sent it an int value 100. The turn left method is default to 90 degrees if we don't pass a value. If we want it to turn a different amount, we can send how far to the left we want it to turn in degrees. When defining a method, the list of parameters can contain multiple parameters. For example, when this method is called, the arguments fed to the doMath method must be correct type, must be in the same order. The first argument must be an int. The second argument can be a double or an int. Arguments can be either literal values or variables. Sometimes we want a method to return a value. In order for a method to return a value, there must be a return statement somewhere in the body of the method. We must also declare which type of data value will be returned in the method declaration. This can be any primitive data type, a Java class, or any class that you defined yourself. If a method has no return value, the keyword void should be used. In order to call a method legally, you need to know its name, how many parameters it has, the type of each parameter, and the order of those parameters. The information is called the method signature. The signature of the method doMath can be expressed as. Note that the signature does not include the names of the parameters. If you just want to use the method, you don't need to know what the parameters' names are, so the names are not a part of the signature. Java allows two different methods in the same class to have the same name, provided that their signatures are different. We say that the name of the method is overloaded because it has different meanings. The Java compiler doesn't get the methods mixed up. It can tell which one you want to call by the number and types of arguments that you provide in the call statement. You have already been overloading used in the system.out object, which is the instance of the printStream class. This class defines as many different methods named printLine. These methods all have different signatures, such as. In addition to these, we've been using this concept with the drawing tool class and its left turn method. It is illegal to have two methods in the same class that have the same signature, but different return types. The Java compiler cannot differentiate return values, so it uses the signature to decide which method to call. 3 categories of Java variables have been explained thus far in these lessons: instance variables, local variables, and parameters. Lifetime of a variable defines the portion of runtime during which the variable exists. When an object is constructed, all of its instance variables are created. As long as any part of the program can access the object, it stays alive. A local variable is created when the program executes the statement that defines it. It stays alive until the block that encloses the variable definition is exited. When a method is called, its parameters are created. They stay alive until the method returns to the caller. The type of variable determines its initial state. Instance variables are automatically initialized with a default value. 0 for numbers, false for booleans, and null for objects. Parameters are initialized with copies of the arguments. Local variables are not initialized by default, so an initial value must be supplied. The compiler will generate an error if an attempt is made to use a local variable that has not been initialized. Scope refers to the area of a program in which an identifier is valid and has meaning. Instance variables are usually declared private and have class scope. Class scope begins at the opening left brace of the class definition and terminates at the closing brace. Class scope enables the method to directly access all of its instance variables. The scope of local variables extends from the point of its definition to the end of the enclosing block. The scope parameter is the entire body of its method. The class scope test is created with 3 methods. The results show the following about the scope of the variable test. Within the scope of main, the value of test is 10. The value assigned within the main method. Within the scope of print local test, the value is 20, the value assigned within the local test method. Within the scope of print class test, the value of test is 30, the private value assigned to scope test, because there is no value given to test within the print class test method. Within the scope of print param test, the value of test is 40, the value sent to the print param test method.